Good afternoon, everyone. My name is Mark Ryland. I'm the director of the Office of the CISO at AWS. We're here this afternoon to talk about the Instance Metadata Service. Welcome to the session. How are the energy levels out there at 4 p.m., late in the week? Everybody? Yeah, all right. I have a lot of energy. This is my finishing sprint. It's my last talk of the week. I have a couple more customer meetings and then red-eye home tonight. I live on the East Coast, so this is my finishing sprint. So I'm going to be high energy. I hope you are too. We're here to talk about a very interesting topic. Instance Metadata Service is a very important part of the EC2, or sort of sub-service within the EC2 service. Here's our agenda. We'll talk about the Instance Metadata Service itself, kind of a level set, so we're all on the same page. It's well known, but hopefully we'll make sure that we all have the basics. Then we'll talk about some new capabilities we've added just a few weeks ago, which we call Instance Metadata Service version 2. Then we'll talk about best practices, which apply to both version 1 and version 2. Most things that you want to do in terms of taking care of the data stored inside the service is applicable, whether you use the old approach or the new approach. And then a call to action. And sprinkled throughout this talk, I've got some screen capture demos. I'm getting old and gray. I don't do live demos anymore. I've had too many of those. The demo god's not smiling on me, but I've recorded some demos, really exciting CLI demos, so we'll get to watch terminals doing things, so very exciting. But it helps communicate, I think, the basics and drive home some of the ideas and the points that we want to make as we go through this topic. So let's reintroduce the good old Instance Metadata Service. The IMDS has been there from early days in EC2. It's a special link local address that you talk to, and you do an HTTP request, and you get back a lot of really valuable and interesting data. Now, that network address is a magical network address, okay? It's really just a way to talk to the EC2 control plane. So the implementation details over time change and have varied. They will vary in the future, but one thing that you can count on as a kind of reliable semantic is that when you call that IP address, you're talking to EC2. You're not talking to any other node on the network or any other instance or what have you. I suppose you could set up some crazy local IP table rule to translate it before it hits our network to do something else. But in general, this is a way to talk to EC2. The HTTP request model is I'll call it a universal language binding. Every language in the world has libraries that make HTTP requests very easy to make, and to take those, whatever comes back, whether it's XML encoded or text encoded as this service is, and do something with the data that you got from that request. So it's just a very general, easy way to access data from any language, or from the command line, as we'll often demonstrate in the demos. The concept here is introspection. So there's data in the metadata service about the instance where you're running, where your code is running, or whether you as a user are logged in if you happen to be running interactively in EC2. There's a ton of really interesting data there, all kinds of stuff about anywhere from some information about the kind of cryptographic signature of your environment. There's some information there. There's things about your IP addresses, the virtual MAC addresses of all the ENIs that are attached to your instance. Public IP addresses are available from there. You can go through this documentation I have linked here, and you'll find just a ton of really useful information for writing software. Typically, again, we're going to demo this interactively, but that's kind of not the normal use case. The normal use case is you have software running there that needs to understand what's going on in its environment and customize its behavior accordingly. My favorite is Launch Index. It's kind of a little obscure, but as you know, when you do EC2 run instances, the API, you can say default is 1, but you can say 100 or 1,000, and you'll get 1,000 instances with one API call. There is a concept called a reservation, which is essentially the indicator for the call, and then as the instances spin up, they get numbers. So if you call for 1,000 instances with one API call and you get one reservation, each of those instances will have a unique index number from 0 to 999. And you can reason about like cluster building. Like you can say, hey, eventually I have to have something fancy like Paxos to decide who's the leader of this cluster, but to initialize my cluster, I'm just going to say whoever's 0, you're elected as the leader initially. So there's some cool capabilities in there. So that's kind of use case one, introspection, stuff about your environment. Use case two, super, super important use case is this thing called user metadata. This is data that you pass in when you call the API for run instances that then shows up in a special place in the metadata service. Moreover, not only can you pass data, but you can pass code. So you can put shell scripts in here or in Windows PowerShell. And that allows you to do anything, completely arbitrary customization of the environment. Run any code, run any script, download things. I get a simple example. We're going to return to this in my demo of I'm going to install a Apache server, a PHP extensions, start the server, et cetera, and download some files to actually initialize a simple a PHP application. So that's a second really important use case, user data. And then thirdly, another really important use case is role credentials, which if you deploy an EC2 role to be assumed by that instance and to call APIs, that credentials for that role are also available through the metadata service. Now there's a challenge here. The challenge is you're trying to get code from an unauthenticated state to an authenticated state, right? You basically have to pass some kind of secret to that code in some kind of safe and sane way. And role credentials allow you to do that. If you look back prior to the launch of role credentials, say June of 2012 when it launched, I actually started, I'm an old timer, I've been at AWS for 8 years, so I actually started in September of 2011. And when I started working at AWS, there was no good way to do this. There was a lot of fairly unsafe practices for deploying to your software the credentials it needed to do something interesting. So actually, one of the best practices at the time was to pass credentials through user data, because at least that way it wasn't in your deployment pipelines necessarily, or actually in your source code, which is like the worst thing you want to do for credentials. But it still was kind of not great because the user data was persistent over the lifetime of the instance. And you were passing long-term credentials, they weren't being rotated, et cetera, et cetera. So a lot of bad things were happening, and the best practice wasn't that great. So role credentials really solved a very fundamental problem. And since that time, you can think of it as being a savior for millions of times people would have made big mistakes for getting credentials to instances, and they didn't have to do that because they got credentials deployed securely. Those credentials are temporary, they get rotated frequently, and they're accessible from that local software on the instance and only from there. So how do you keep this private data safe? Role credentials, obviously one of the important parts of the private data you want to keep safe. And a lot of the safety is sort of built in. First of all, as I mentioned, it's this link local address. Unlike a normal link local address, which allows you to talk to other hosts on the same subnet, it's essentially a broadcast-based resolution. This doesn't even work in a subnet. It doesn't go anywhere except it allows you to talk to EC2. Now, just as a little side note, implementation detail, this could easily change, but right now, in a Xen host, you're talking to the DOM0 and the hypervisor, and a Nitro host, you're talking to one of the Nitro controllers. And they're the ones that are responding to you when you make this request. But again, that could change, so don't count on that. But what won't change is you're talking to EC2. So first protection is link local address only available locally. Another protection that is really important, we'll keep emphasizing, is when you do use roles, and again, the typical use case is software deployed on an instance, using these credentials to call APIs, you've got to do least privilege analysis, figure out what APIs do I need to call from this instance, and then limit the power, the scope, the privileges of your role to what is actually needed by that software. And frequently, that could be very small, very limited. It doesn't need broad administrative powers. Don't put those star.star kind of privileges on your instance roles. And finally, you can also use local protections because the local firewalls on either Linux or Windows can be used to scope down to particular processes or particular local principals who can access the metadata service. And we'll show in a demo ways to do that. And you can see in our EC2 documentation a bunch of examples as well. So all that said, it's worked great. It's a very successful service. We'll continue to support version 1 essentially indefinitely. But it is possible for people to make mistakes and do things on the instance where the software they're running somehow exposes that private data, the instance metadata service. Whether it's credentials or something else, there are misconfigurations that can occur. A great example is if you have an open proxy and you install a web listener that listens for web requests and says, hey, send me a web command and I'll just repeat it on down the line for you. Well, that can be abused and used to access data coming from this link local address. So that's kind of the HTTP level. And some software, there's various kinds of misconfigurations and problems, or potential, you could call them vulnerabilities. Typically some web app that does, they're usually called webhooks, like this kind of a little API where you can pass a URL and say, hey, do that URL for me and send it back. This can cause problems. At the next layer, below layer 7, layer 4, TCP, that can be misconfigured as well. You might have some kind of funky NAT configuration or some kind of router configuration or whatever that somehow gets a packet to the instance, and the instance is configured to forward that packet to this link local address and happily forward the reply back, and again, that can cause problems. So given that, and given the fact that people have made these mistakes, we've been thinking about how do we improve this? How do we make it safer? One thing that has been suggested, and it's actually implemented in some parts of the industry, is like, hey, just add this header to the request, and if the header is, some magic, hey, instance metadata header, then that would protect me. The truth is that doesn't actually work. It works in some cases, but in many cases, the open proxies or other systems that get misconfigured will take headers and send them forward for you. They'll send them along, down the line. So a clever, slightly sophisticated attacker who finds an open proxy will just send the header along with the request, and it'll happily send back the data that it shouldn't send back. So we want to protect against some of these as well. So I want to introduce Metadata Service 2.0. As I mentioned a couple weeks ago, it came out. And we're going to go into kind of gory detail about a lot of things here, but the fundamental idea here is let's make the access pattern sufficiently unusual that the typical misconfigurations are just not going to cause you trouble anymore. Now, you notice I'm using careful language here. I say it's going to defeat most known configuration mistakes. I'd like to make a slightly stronger claim. It will defeat all the ones that we've ever found and tested. So when these problems occur, and we work with customers on those, we create a little library of these problems. And for now, when we run this new metadata service interaction against those known problems, this blocks all of the problems. But it's still a problem to get software from an unauthenticated state to an authenticated state. So it is conceivable there could be software out there that's misconfigured in such a way that it will do this new, more sophisticated way of acquiring the ability to talk to the service. So I can't say it's impossible by any means. In security, you never say things are impossible, right? But the risk mitigations here are very strong, so we're confident this is a big improvement, and we're going to go forward with that. But we're also going to recommend, and you'll see most of my best practices apply to both versions of the service. It doesn't matter V1, V2. There's a lot of things you need to think about to make sure that you're safe and secure. So what do we do specifically? We turn this request response model into a more logical session-oriented model. So the first request is a special one. It's a put verb, which many, many proxies will not forward. Special header you have to send, and then you get back a token. There's some limitations we'll get into about even the TCP level around that particular request. Once you have the token, you add that to the headers of subsequent requests, and you continue to use that session essentially until it expires. So let's be very specific here. Simple bash example pretty much tells the tale. We'll do a curl, copy URL command. We'll make a put as our HTTP verb, talk to a special URL within that link local address, and we'll send a header in that says, how long do we want this token to last? In seconds. Maximum time, 21,600 seconds, which I think is 6 hours, which is about the time of the kind of longest possible time of the lifetime of a role credential, so kind of matches that. Once you have that token, and we'll see this in the demo, what it looks like, I've now got it in a little shell variable there, and I can do GET requests and send that token back in a header, and then the service works as it did before. This particular token would expire in 10 minutes, because I asked for 600 seconds. And this is a critical point. Both version 1 and version 2 are the same link local address, same listeners, but I distinguish, my metadata service distinguishes between whether you want to talk to me on V1 or V2 by the presence of these headers. Absence of the special headers, you're talking V1. Presence of the special headers, you're talking V2. Question, can I disable V1? Yes, we'll talk about that. Another question, can I disable the metadata service? Yes, that's a new feature. Sometimes you may not want one at all. Why have it there? Why have something that could expose data where you don't need that data to even be used on that instance? Now you can turn it off. We're going to go into all this in gory detail, believe me, because we still have 5 minutes almost. But that's the gist of it. So some more details. You initialize the token, it lasts for a certain number of seconds. The token is special. It's not usable on any other instance in the fleet. So you're welcome to test this. I promise you that that token only works on that instance where it emerged from. Another useful protection is on the put request, we look for X404 headers and we reject put requests, the token acquisition request, if there is an X404 header. Why? Well, because obviously a lot of proxies who, even if they're willing to do a put verb, which is super rare, they almost always will add that header because the recipient wants to know the IP address of the caller, original caller. So that's just not an appropriate use case for a metadata service, so we reject those calls. If you go down to the TCP layer, or actually IP, strictly speaking, we also treat the put request a little differently than normal, because what we do is we say, okay, when you say put, we know you're talking V2. So your new software, you've been upgraded, you're aware of this new service. What we're going to do is we're going to send you back an IP packet that has a TTL of 1. That means if there's anybody else listening there that's going to forward that packet on to some other host, then very likely they're going to decrement the TTL, and that packet will just die. It'll be black hole because what'll typically happen, the software sends back an ICMP message saying, sorry, TTL dead, I just killed that packet. Point is that by default, that packet will not tend, again, you can imagine crazy software that doesn't honor this, but in general, this is going to be a very safe way to make sure that at the layer 3-4, that these put requests will not ever traverse beyond the host where your software is running and calling the metadata service. Now this is configurable. Why? Because there are valid use cases, and the most typical classic one is that container networking will often run some kind of like a little NAT type of scenario there, and it'll decrement the TTL to pass it on to the container. So you might need to use 2 or 3 as your TTL. You've got to test it. Default is 1 because you have to have upgraded software, and if you're upgrading your software, you better be testing. And if once your testing shows you that you need a TTL of more than 1, then just launch the instance with more than 1 or modify it with the API that allows you to change what this TTL setting is. So that's another important point. You can vary it from 1 to 64. There's no practical limit to the number of tokens that this system will emit to you, so you don't have to worry about like, oh, I've called this too many times, I've got 100 tokens in play or 500 or whatever. Don't worry, it's going to be fine. That said, I mean, don't be stupid in terms of efficiency. It'd be perfectly reasonable and probably recommended that if you're going to create a token that lasts, 10 minutes, just reuse the same token for 10 minutes. And if you ever get an unauthorized error, then get another one, or use your own counter, your own timer to renew it, every 5 minutes, whatever. But the point is that you don't have to worry about, gee, am I kind of overusing these tokens? There's plenty of them. Now, there are limits, and you can read the documentation around the IMDS itself, version 1 or 2. It does have some throttling and limits around, trying to avoid abusive calling that will potentially slow the whole system down. But those are, pretty extreme. You typically don't need to worry anything about that. All right. So let's do the basic demo here. And then if we have time, we'll do some slightly more sophisticated, a little bit fancier demos as we go along. Before that, I want to make clear certain things, because if you're staring at a screen and you see these little terminal things flashing by, it's not always super clear what's going on. So I want to kind of create a mental model for you about what you'll be seeing on screen. We're going to be logging an instance. We're going to be using that arguably not super common scenario of being a human being using the metadata service as opposed to software. I mean, we're driving software, but it's an interactive use case. But there's three very different kind of access patterns that we'll be effectively doing here. One is, number one, we'll sometimes be calling the EC2 API. And we'll be doing that to launch instances, to modify instance metadata, which is a new API, or something along those lines, okay? We'll be calling the EC2 API, and anybody that has access to the API and has the right authorization, the right credentials, could be doing these calls. Now, what's a little confusing, perhaps, is because of the demo, we'll be doing that from the instance, right? So we'll be using credentials that we got from the metadata service by calling call pattern 2, to sign the request that we're making, then we call the EC2 API. But just be clear that some of the things we're showing, and by the way, I'll show by experiment that the AWS CLI, it calls the metadata service every single time you run a command. It doesn't actually cache credentials or tokens. So that you'll see if I type, AWS STS get caller identity, so I make an API call, and then I disable the metadata service, and I try it again, it fails, because I have no credentials, so it's actually calling each time. Again, a lot of software. I don't know what the SDK defaults are. I forgot to, or just never got around to going and looking up in the source code, which is available. I suspect the SDKs will cache these tokens for you and not use them every single API call. But for the CLI, it kind of makes sense, because in these interactive use cases, that's exactly what you're going to tend to be doing, is experimenting, trying things, what have you. So the CLI will actually refresh each time. So that's kind of the setup. Now let's go to my exciting visualization here. 2 terminal windows. Now these happen to be logged into the same instance, and I'll explain in a minute. You'll see why in a second. And let's run our little demo. All right, so first thing we're going to do is the thing we've all done a million times. Curl on the metadata service, get back a list. Everything's fine. That's all standard version 1. Now we'll try this new mode. We'll say, okay, I want to do a put. I get back, I put in the header that said I want this to last 60 seconds, and I get back this long string that's a token representing this session. Now I'll use the token. I'll take the token, copy paste it into a GET request, put it into this header, the metadata token header, and I'll hit enter, and I get the same result. But this time I talked version 2. Previously, I was talking version 1. Okay, now let's try another thing here. Let's try the token length. Okay, I'm going to say this token should last for 10 seconds. Okay, and I put that into a shell variable, and then I do a curl. Okay, 7, 8, 9. I get a result. I try again, and I get unauthorized. My token expired. Okay, that was like 12 seconds, so it doesn't work anymore. All right? Let's try another little variation here. This time I'll do a 60-second token, get back my response. So this is all kind of normal for the put operation. Now I'm going to add an X-forwarded header. And I get essentially access denied. So I get an unauthorized exception from the web server that I'm talking to, the EC2 service. Now we'll do kind of a normal token. This will last an hour. So we're going to use this for the rest of the demo. No more refreshing. I'm going to put the instance ID of my instance in a variable. And now I will call the modify API, EC2 modify instance metadata options with my instance ID. And now I see the defaults because I haven't changed anything. Ignore for a second the pending. I can describe that. HTTP endpoints enabled. So metadata service is there. Optional means 1 and 2 are both working. If a token was required, that would say required. And then the hop count is there as well. Now, same instance, I'm going to run TCP dump. So I'm going to watch the traffic between my CLI and the metadata service, watching for packets on that have port 80, either source or destination. Do the call, You see the TTL of a normal version 1 call is a kind of standard TTL, 255. Now I'll do a version 2 call, a GET. Same thing, nothing special about the GET operations. It's only the put operation that's impacted by this new setting. Now I'll do a put, and you can see on the right side a TTL of 1 for the packet that's coming back to the CLI. Now I'm going to modify the hop. So I'm going to call the modify API with a hop limit of 3. And you see it responded and said, fine, I'm going to do this for you. Do the same call, and you can see on the right side the TTL that TCP dump is showing us is 3 hops. So we'll kill TCP dump. We'll do one more little demo here, and that is we're going to turn off version 1. So now I've asked the metadata service, say, require version 2, require token. Okay, so now I'm going to try version 1. I'll do this simple curl. Because it's the way curl works, it doesn't show me why something went wrong, but I didn't get any results, so I'll turn on the verbose option. Try again. Now I see that I have an unauthorized exception. So basically, there's a security problem with my request because version 1 has been disabled. And then finally, to kind of close this system out logically, we'll try version 2, and it works fine. Okay, so it's in version 2 mode, version 1 doesn't work anymore locally, and so forth. Now, one thing to be clear is, again, it's the software on that instance that's general kind of available software can call either one of these 1 or 2 APIs, but when I hit the required mode, only version 2 will work, version 1 won't work. There's also, and I'll emphasize this several times, this is a breaking change for a lot of software. So don't go around willy-nilly like disabling version 1 without some very careful testing, because you're going to break things, I promise you. You got to be careful, you got to do some testing, got to upgrade to the newest SDKs, you may have to talk to partners, and even Amazon Web Services software, frankly, will break right now because we need to upgrade some of our agents. So if you're running like a systems manager agent or inspector agent, those will get upgraded quickly, but right now they're not going to be using this new version. So caution and care is required, but it's a journey. We're going to go on, and we're going to give you a bunch of tools to make this transition, and we'll talk a lot about that as we go on. So what are some of the ways we support the transition? Well, first of all, as you can see in the demo, there's a new API which allows you to modify these properties at runtime. So you don't have to restart instances, you just call the API. And now it's going to be loosely consistent API, and that was why that had that term pending at the top every time I called modify. It's pending because it could take 1, 2, 10 seconds, right? You may have to wait a little bit. In practice, it seems to be nearly instantaneous from all I can tell, but you can't count on that because this is a big distributed system. So, after a little while, the call that you make to modify a running system will be applied, and the behavior will be changed. But equally importantly, when you start an instance, you can specify which of these parameters you want to be using the new parameter values that we'll talk about in gory detail. Actually, so let me pause myself for a second. This is actually a kind of a summary slide, which I'm going to go over really quickly because I'm going into each one of these in more gory detail. So, new APIs, new condition keys, CloudWatch metrics, software updates, and a few other things that are coming soon. So let's go into the gory details. So first of all, run instances has new parameters. You have defaults, which result in the standard old behavior. Version 1 will be there, service is enabled. The hop count is 1 because, again, that only applies when you're upgrading. So it can be the most restrictive and not cause any problems. Because remember, you're not going to use this until you start testing, right? You can also do describe calls, and I'll show that in a minute. You can do a describe call, and you can filter on these options, and you can create little reports about what the state of your instances are, like which ones have been disabled, what's required. Very easy to do with the describe call. And then finally, the new modify instance metadata options API. Oops, there's a typo there, sorry. It should be API, not APN. APN. If you call this API with no parameters, it just returns the current state, so it's kind of becomes like a little micro describe call with that for that instance. And then if you, of course, would call with parameters, you can change the state. Now, you also have new condition keys in your IAM policies and SCPs. So now you can do access control-based control of the behavior. And we're going to do a demo of this, so I won't belabor this right now. But you can put in condition keys which say, if the person calling this API doesn't use this parameter, fail the call, access denied. Okay, so that gives you control at some point in the future as you migrate to lock down and eliminate certain settings that you don't want to be present in your fleet. In addition, so that's kind of that, remember that arrow where I showed 1 coming into the EC2 API? And then I also showed this arrow 3 kind of going out from. So I've got credentials on the instance, I've signed a request, I'm calling out. In that call, there's a new property called the role delivery, which allows me to write a condition in any Amazon API, EC2 or otherwise, which allows me to distinguish between calls signed with credentials delivered by version 1 or calls signed with credentials delivered by version 2. So very much belt and suspenders as you enter this process and get near the end of this process of migration, if you choose to migrate, you don't have to, you can actually begin to lock down and say access denied if a call was signed with the older version of credentials, the credentials that come from the older version of the metadata service. Again, we'll do some demos on this to make it clear. Here's our access patterns again, which we'll kind of go back to. So the first set of IAM conditions apply to calling the EC2 API, and with the little gray arrow controlling the behavior of the metadata service. And the other one IAM condition applies to calls that are made with credentials that come from the metadata service. Okay? Hopefully that's clear. Now, in addition to those controls, you also have this really handy CloudWatch metric. For every instance, we now emit a counter of how many times someone's calling version 1. So the name of this metric is metadata no token. You can see kind of at the very, oh, I haven't shown you the screenshot yet, so we'll get to that in a second. CloudWatch metrics. You can use it to count. I'll fast forward to that for a second. So this is what it looks like. For any given instance, I can look at this metric, EC2 metadata no token, and I can see the number of calls per minute, and I could even alarm on that. Like if I'm at a place in my migration where I've migrated to, say, I want everybody to use version 2, I can set alarms on that, and if any software happens to still be out there calling version 1, I can get an SNS notification, whatever, any type of alarm or metric that you want to do with CloudWatch. So that's very useful. We've updated the CLIs and SDKs, so we've started the process of all the software upgrades that need to happen. That's the core one, obviously, because you need to start using this right away if you want to use one of the core tools. And another really important launch that's coming just very soon, a couple weeks out, hopefully, within the next 2 to 3 weeks for sure, is launch template support. Why is this so important? Because launch templates are a very important indirection now for this whole ecosystem of APIs, so that they don't always have to be revised every time EC2 launching is revised. So if you're doing auto-scaling, CloudFormation, various other things that launch EC2 instances, you ought to be using launch templates, and in this case, you will have to use launch templates, right? We'll just make it so that launch templates are the indirection that you use to use this new set of features. Another thing that will come soon, can't say exactly when, but soon, is we'll start logging in CloudTrail whether a call or request was signed. You already log the fact that it's EC2 instance, role assumption, the instance ID. It's already there in CloudTrail when EC2 roles are calling things, but we'll add the role delivery as a property. So you can, in CloudTrail, also track whether version 1 or version 2 is being used. We've already seen this screen. All right, let's move to best practices. So again, most of these apply to version 1 or version 2, doesn't matter. And I'll start with bottom line up front, one of these horrible business acronyms, BLUF, bottom line up front. It's not logically in order, the rest are kind of more logical, but obviously the greatest risk applies for the metadata service when you have instances that are reachable broadly. Like if they're on the internet, you got to be careful. There's bad people out there. They're trying to harm you. So metadata service, like any software that's on public-facing things, manage it carefully. So focus there if you're concerned about this risk, and it's one of those things you need to be concerned about. Focus on your servers that have broad accessibility. Limit the software, limit the processes, do these other protections. Start there, okay? Okay, we'll bracket that, and we'll talk now just kind of logical ordering of best practices. First of all, does any software need access to the metadata service? Sometimes nobody does. Disable the darn thing. Why even have it running, okay? That's step one. If it turns out that they need access, fine. You can enable it. But what about, then think about local protections. I can limit it so that only a single process on the host can access the metadata service. And it may just be that one process that runs my software that has to access Secrets Manager and get some database passwords or whatever it is. Lock it down locally. And that way, if some other crazy software on the host ever gets compromised, it doesn't matter. They won't be able to reach the metadata service. We'll give some examples of that. The other thing you can do is a broker model. You can have some more trusted software whose job it is to access the metadata service, and then it can take some of the data of your choice and just put it somewhere in a text file, and other software can pick it up. And I'll do a demo that does exactly that. It's a very useful pattern, and in fact, works well in these case of user data, and that's the demo, essentially, is when I initialize the instance, I grab some data out of the metadata service, put it in text files, and then I turn off the metadata service, or I block it with a firewall rule. From then on, I'm very safe on that instance. So that's another thing to think about. Next question, does any software need to call APIs? That's when you need a role. If you're not calling any APIs, AWS APIs, don't assign a role to the instance. Okay, just don't do it. Just creates risk. Now again, there's some really interesting special cases, like you might say, well, I got to call a database. In that case, okay, fine, you might need the role because the secrets manager is probably the best way to manage that secret. So now you have this indirection. You say, okay, I've got a role very scoped down. The only thing that role can do is it can get a secret from the secrets manager and then use that for database calling. That's fine, but just scope it down. Just to that one secret. You can use resource ARNs in your policies to make it so no other secrets are accessible. There's no other APIs it can call, et cetera, et cetera. So think about that in terms of whether you need a role and what that role is going to be doing. And then, the kind of general, most important overall general advice when it comes to role management is think about least privilege access. Think about what is the absolute minimum things this thing needs to do, and I'm going to write my policies to make sure that it can only do those things. If I have multiple processes maybe that need credentials or need access to something, I can use this kind of a broker model. So these are all the kind of steps, logical steps to be careful with managing the service. And of course, keep your software up to date, the usual talk around. I shouldn't say it like it's a joke, but if we want to be secure, we want to patch our software. All right, so let's do some more demos. Now this is kind of a little bit of an indirection, but I'm going to demo a little kind of cheesy piece of software that I wrote as a demo, which used the metadata service quite a bit. And then I'm going to show kind of like modify it and show safer ways to do it now that I'm preaching, as I should be, the gospel of limit access to the metadata service. So in this case, I have this little, two things basically. It's a JavaScript application. So you can see it's very out of date because I'm missing a bunch of regions, but this was the global infrastructure as of like 2 years ago, and I apologize for not updating this demo. But basically the idea here is it's a JavaScript application. The users and the audience in this case, if you're trying to, this is a way to communicate to the average user, like what is the cloud, what's the power of the cloud, blah, blah, blah. So what it does is it says, okay, load this URL in your browser, and then I'll go over to this little shell script, and I'll just start launching instances, and I'll launch them around the world. So I say run 4 instances in every region, and the shell script goes and starts doing, run instance. And the demo, the JavaScript, which is polling the EC2 API every 2 seconds, starts to show the instances launching globally, okay? And they're initially in kind of a startup state with the blue, and then they begin to turn green because they're now in the running state in terms of what the API. And again, this is all JavaScript calling the API from the browser. So now I've launched, 16 times 20 times 4, it's like 64 servers around the globe. And I can hover my mouse over these things, and the EC2 API will tell me various things about them, their instance ID, their IP address, et cetera. Now I'm going to stop 2 of the 4 with another command, and you can see them start to, shutting down state, and they turn brown, et cetera. But there's one other thing I wanted to add, which is I wanted to make it more real. So I said, I want to make it so that if you click on one of these, you actually talk to the server that I just launched, okay? So that was added as a feature to the little demo. Now you'll notice if I click on that little pop-up, and I'll go over to Germany, click on a pop-up, and I'll click on the public IP address of that server, and I'll actually go to that host, and I'll run a little PHP application. And the application says, where am I, what's my availability zone, what's my IP address, blah, blah, blah. So it's kind of a, I think, cool little demo. And you can see we can go to Mumbai, we can go to Singapore. And in each case, I'm actually talking to an EC2 server that I just launched with this simple little PHP application, telling me what's, where it is and kind of what it's doing. So now, what's the point of that? So there's like the old joke, well, I told you that story to tell you this one. Okay, so now we're going to modify this little demo so that these PHP servers, which is not necessarily the safest technology in the world, don't have access to the metadata service. So in the old version of this app, you can see that I was sending user data and saying, download this PHP app. So everyone I launched downloaded the same code, but then it went to the metadata service, so you can see my PHP, little PHP app, and it's calling the metadata service every single time it gets a web request, okay? So let me pause this real quick so that I can catch up with I don't want to get too confusing here. All right, so what you've seen there is I've got an app, it's calling the metadata service all the time. Like, that's not great. I mean, why not be safer if this was a real app? So what can I do about that? All right, so let's finish my little demo here. First, I'm going to prove to myself that I can control access to the metadata service using local firewall rules. Okay, so in this case, I'm going to create an IP tables rule that rejects calls from the user, EC2 user, which is me. I'm logged in as a shell. I look at the IP tables list command, and I see this little reject command down there that applies. Using the owner module, you can actually use the process owner's identifier, the principal, as a rule that says who can call an IP address. So now when I try curl, you see it just times out. So I've effectively blocked myself from talking to the metadata service. Again, version 1, version 2 doesn't matter. I'm now blocking myself at the IP level. So now I delete that rule, the rule's gone, try the same call again. It should work, hopefully. Oh, I recorded this demo, so it does work. Now, let's try it on this little application. Okay, so I'm running this little application on the very same server that I'm logged into with the shell. It's telling me, you can see when I recorded it, not that long ago. And it's got the IP address, the ID, blah, blah, blah. And again, looking at the source code for the PHP page, it's just calling the metadata service. Every single time it's refreshed, it calls the metadata service. But I don't want to do that anymore. I'm going to follow my own best practices, even for my little simple demo app. So I'm going to create an IP tables rule that blocks the Apache principal, which is the default principal for Apache when you install it. But I've got to be careful because someone might have changed that, so be careful there. But I'm going to block Apache from accessing the metadata service. And if you look at the the spinning circle of death, we missed it. It's up there in the region demo. So now my PHP app is hung up because it's trying to reach the metadata service and it can't. All right, so how do I make this little cool app, I think it's a cool app, work again? And here's what I do. During initialization of that instance, I'm going to take the shell script that runs, and I'm going to, first of all, block Apache from talking to the metadata service. But secondly, I'm just going to grab the data I need one time, stick it in text files in the directory where the PHP app runs. So you can see I'm essentially curling this stuff and then my PHP app, I'll just pick up the data from a local text file. So very simple code modification. Instead of get, from the metadata service, I'm just pulling up a text file. This version of the app on the same host with the metadata service blocked runs fine. Okay, one version doesn't run, the other version does run. All right, just a few notes now on firewalls, okay. First of all, I kind of violated my own advice just now, but you probably want to whitelist or allow principals rather than block. Why? Because if you have an allow list, people can modify that system potentially later and it won't affect your security decision. You've decided there is a process or a principal that you trust and they can access it. And if someone gets added later, they can't access, right? If you use a deny rule or you say, deny this one principal or these three, then potentially something can get changed later that you're not thinking about or you're not aware of, no one's conscious of, that could access the service, and that would violate your intent. So it's a good idea to think in terms of like, who are you going to allow, block everybody else, rather than block the dangerous things and leave the rest, okay? So that's, again, I violated the principle just now in my demo, but that's a good way to think about it. There's another funky limitation, and I think there's even pull requests to fix this, but the current implementation, the kind of broadly available one of the IP tables owner module, which uses, again, you could use other things. You could potentially use process IDs or other things to do this blocking, but principle seems like a pretty good idea because it requires, root access to change principles and decide which principles a process is going to run in and so forth. The current version only blocks on primary group. So you might have an expectation that you can create like a permission on a group and say every process that's in this group can access. That doesn't work quite the way you might think. They would have to be all associated with the same primary group, which changes other behavior on Linux that you may not want to do. So it's an issue. Hopefully that module might get updated, or maybe someone bright person in the audience will go update it for us all, and then it'll actually inspect all the groups and do the right thing. Now the Windows Firewall actually does the right thing in this case, although it's a bit complicated. You see my one line of IP tables versus this is the PowerShell you need. I'm very proud of this. It took me like 3 hours to figure out how to do this because there's this Windows standard called the SDDL, Security Descriptor Description Language. It's almost completely undocumented, but unfortunately you have to have it in order to create these PowerShell rules. But basically here, I create a user, and the other thing that's weird about Windows Firewall is you can't, there's no implicit deny. Like, so if you block one, you think you're allowing the opposite or vice versa. It doesn't work that way. You kind of have to declare both. So in this case, I'm going to say I've got this principal that I want to block, and I then use everyone, which means create sort of the default deny. And then I create another principal that I call trustworthy users. This is a regular Windows group, and in this case, group membership actually works properly. It doesn't matter whether it has 1 or 10 members or anything at all, because Windows doesn't have a native concept. Well, the Windows API doesn't have a concept of primary group membership. And then I create this firewall rule, which does just what you'd want it to do. Okay, now let's talk finally about access control capability. So now we'll talk about the IAM conditions that you can use to control the use of the metadata service, whether it's the run call, et cetera. Because again, we can control describe instances. We have some control over modify instances. I'll talk about that. There's a few limitations which we'll get rid of, but right now they exist. And then this ability to say whether role delivery version 1 or version 2, that's also worth a look. So we're going to now do an access control demo. So here we go. So we have these three terminal windows. They're on 3 different hosts. So red is a host that is the CLI has not been upgraded. Okay, so this is a naive, old-fashioned client on the red host. It's going to do what software has always done from the beginning of time as far as the metadata service is concerned. There's nothing about version 2, and that's useful for demoing certain aspects of this change. The blue and the gray terminals are on upgraded hosts, so they know about version 2. However, now, so that's the software that's running and its state vis-a-vis the metadata service. However, as I'll show at the start of the demo, in terms of their power, the principles that they're running as, red and blue are running as the same principles, same EC2 role with the same powers, same privileges, and gray is in a different one, and we'll talk in a minute about why. But let's go ahead and start, and I'll kind of walk you through this privilege demo. First of all, who are these principles? You can see the role here is admin on EC2 for red. It's also the same on blue. And in the gray terminal, we're talking to a third host, we have a slightly different role. This role is called EC2 IMDS admins, and you'll see why in a little bit. I've also created variables so that I can talk about red, blue, and green easily by just using variables. Now here is a describe instances query. Like I mentioned earlier, that creates this nice little report. So in this region, for all my EC2 instances, I can see whether the instance metadata service is optional or required, enabled or not, and how many hops it has for the put request. So there was an instance which had optional, enabled, and 5 hops. I'm going to modify it to be required, enabled, and 15 hops. So again, this is live because my describe call, so I'm doing the modify call, doing the describe call right afterwards, and it's showing me the current state. As I mentioned, this state seems to change super fast, but again, you shouldn't count on that. Now I'm going to go to another terminal. I'm going to disable the endpoint. So there's no more metadata service. I'm going to call the same API I just called earlier. Now what's happened there? What's happened is I've blocked access to the metadata service altogether. So when that instance tried to then sign a request, it failed. And I can't re-enable it because I can't call any APIs anymore. So I go to the other instance, I re-enable the metadata service on the gray instance, and then everything is back to normal. So now I can call APIs again. So there you can see that I've essentially, CLI is calling the metadata service every single time. So now, again, I can do sort of standard API calls, and I can do modify calls because I've upgraded my CLI. Actually, the red fails. I'm going to pause myself because I'm getting ahead of myself here. So red just failed because there's a new API and the CLI doesn't know anything about it, right? So it just gives me a list of, hey, you must have meant something else because I don't know what API you're talking about. But let's continue on. And I can run instances. That's an old API, and nothing's changed in terms of my permissions. I can run instances with the new CLI, the blue CLI, or I can run instances with the red CLI. But I'm going to change that because I'm now going to go to the IAM console. I'm going to take a policy that says deny request if I call this API, and I'm scoping it down to resources, and you have to do this for reasons I can explain later, afterwards. If this token is, if the API call doesn't say required, then fail the call. Or if I want to change the hop limit to more than 3, fail the call. So I've now scoped down the permissions for this role, which I'm going to now associate that policy with my role, attach policy. Now I go back to my instances, and I try the same API call. So I get access denied from red, which now with red I can't change. I have no hope here with the CLI because I haven't upgraded, so it's always going to fail. Blue fails as well because I haven't specified new parameters. Let's go to red and try to specify new parameters, and what I get is a different error message, which is, what the heck are you talking about? I'm an old CLI, I don't know what those new parameters are. I go to blue and I do that same call with the new parameters, limiting hop limit to 1, requiring this instance have metadata service version 2, and it works. Okay, so now I can launch an instance. So let's try some variations on that theme. First, I'm going to say hop limit 4, which is more than what I've allowed with the policy. And that call will fail. Now I'm going to try to have the appropriate hop limit, but I'm going to say optional, which is not allowed. And as you would expect, given the structure of this demo, that's going to fail. So I'll go back and kind of prove to myself that all is well, all is right with the world. I'll both require the metadata service be version 2, that's what the token requirement means, and then I'll also make sure my hop limit is less than 3, and now I can launch an instance again. Okay, so we're done with that part of our demo. Now we're going to talk about this other thing, which is role delivery, like what happens to the calls I make with the credentials I'm getting from the metadata service. So the red terminal doesn't know about version 2. It makes a call. I've now essentially, I'm going to block that I'm going to make the metadata service required on red, and then it'll try another API call, and it'll fail because it doesn't know to talk version 2 protocol, so it's unable to get the necessary credentials. So in this case, the CLI responds locally and says, sorry, I don't know where the credentials are. But let's re-enable the version 1 on that server, make them optional again, and then try again, and it all should be well. Okay, because it's able to talk version 1. Now we're going to do the outbound scenario. So in this case, I'm going to say the credentials must have been signed with, the call must be signed with credentials that came from metadata service version 2. So to do that, I'm going to add a policy to my role that has this structure. So I'm going to limit calls to credentials that have the numeric less than, in other words, it's got to be at least 2.0. This would be future-proofed. If there ever was a 3.0, you would still allow calls. Attach that policy to the same role. And then when I do a call from the red guy, who a minute ago was able to launch instances, now that call, even though it doesn't have the other restrictions, it's going to fail because it doesn't have the right kind of credential. So I get another type of access denied. And if I go to blue, actually I'm going to pause for a second there to explain where I am here, sorry. Yeah, so I blocked on red because I've required version 2. All right, now the last part of this demo is to, let me explain something here. So the modify API does not yet have fine-grained access control. So you can't yet limit the modify API the way you can limit the run instances API. Now we're going to fix that, but it's just telling you the current state of the world. So you can't, for example, say only allow modify if put is less than. You can't do that yet. Give us a few weeks, it's coming soon. But if you think that if you're in the process of upgrading and you want to restrict access to the modify API, that's a very reasonable thing to do. So what I've done in this case is I have a special role which does have the power to modify the instance metadata service, but other powerful roles don't have that. All right, so let's continue on. So Blue Server, which is a pretty powerful role, is able to call that API, but now I'm going to add a policy that says you have to be in this IMDS admin role in order to modify the API. Attach it to both the role of the blue terminal. I'm also going to attach it to the role of the gray terminal. So they've got the exact same policy attached, but one of them is in the role that's permitted. So now what happens is what you would expect is that you can not call this API from blue. You'll get an error message. But you can call it from gray because this is part of a privileged role that has access to the metadata service. Okay. All right, I think that's the end of my demos. So I should just say in passing that you can apply every single one of these policies I just showed you is in our documentation. It went live yesterday. And you can take they're all deny policies, which means you can turn them into service control policies. So if you're using organizations, you can literally copy and paste every single one of those policies, put them in a service control policy, and it will block everything in the environment. Now beware, it'll block the console in that case because the console doesn't yet have the ability to set these new parameters, but again, that's coming soon. So let's skip to the conclusion. Call to action. I think you can probably understand what this is going to be because it's really just a repeat of my best practices, which is, start with your systems that are very broadly accessible, right? That's where the greatest risk is involved for whatever private data is in the metadata service. Well, even if you're not using roles, there's still data in there you probably don't want exposed. Then decide about migrating to version 2. Some customers are perfectly happy with version 1 and it works great. You make your own risk assessment. You don't have to migrate, it's all fine. If you decide that you want to do that, you can do that. So start with the risky systems, disable the IMDS if it's not necessary, don't use roles unless you have to, look for that least privilege kind of thing. If you do go to version 2, assess the risk, decide about migration, and then start the migration for example, upgrading software. You got to start upgrading software. You watch the CloudWatch metric to watch your count go down to 0 of software using the old version. And then eventually you can begin to lock down version 1 so it just doesn't work anymore using both these controls around starting new instances, modifying them, or using credentials that come from version 1. So thank you very much for your time. I appreciate it. And have the rest of the week, only one more day. Have a great week. Thank you very much.